This is the mask that covered the head of the embalmed king Tutankhamun. It is surely the most wonderful funerary mask that has survived to our day. Here we have a hollow but substantial gold helmet showing the head of the king wearing the characteristic striped wig cover of a pharaoh and the falcon funerary collar. All the details are inlaid in lapis lazuli, carnelian, and colored glass. On his brow are the protective deities of Upper and Lower Egypt, the vulture and the cobra. The face itself is that of a young man in the early bloom of maturity. It is clear that this mask, made of gold, the very flesh of the gods, is of a divinity, as the long plaited beard proclaims. We are looking on the face of a majestic immortal. But if you take a less reverential and more inquisitive look at this piece, then the full wonder of it will dawn upon you. Because it is apparently made out of a single lump of gold, there is no trace of any seam or join, as may be seen from this X-ray of the mask. Thus, it must have been made purely by hammering and not by modeling or casting.
In several of the tombs of the nobles at Thebes, like this one of the vizier Rekhmire, scenes of craftsmen working in metal have been recorded. Some of them are beating out large metal vessels of silver or gold, like Tutankhamun's mask. Others are at work polishing these vessels or hammering designs upon them with sharpened bronze tools. Tutankhamun's Egypt was a Bronze Age civilization. Its most commonly used metal was that alloy of copper and tin we call bronze. The use of iron was almost completely unknown. The ancient Egyptian craftsmen were also able to cast metal, heating up the material in crucibles and pouring the molten metal into molds. In other ways, too, the technology of the ancient Egyptians was little inferior in its results to our own. A substance greatly prized in the ancient world was lapis lazuli, a naturally occurring blue stone. The source of supply was centered in Afghanistan. From there it was exported all over the ancient Near East, even as far as Egypt. A lapis lazuli figurine of a woman was found in Upper Egypt that dates to the very dawn of history, some 5,000 years ago. The ancient Egyptian chemists wanted to imitate this most desirable but rare and expensive substance. At an early age, probably by about 2700 BC, the ancient Egyptians had solved the problem and discovered a calcium-copper silicate which closely imitated pure lapis lazuli. With this artificial substance, they were able to make such objects as this cylinder seal and this large scarab beetle amulet. Egyptian blue, as this substance is called, was also powdered and used as pigment or paint. So the ancient Egyptians had a kind of science, but it differed markedly from what is understood by the term today. They had collected a body of wisdom as the result of careful observation, trial, and error. With this knowledge they could solve practical problems, for example, in the field of mathematics. This papyrus in the British Museum and other similar texts show that the Egyptians possessed a decimal system of numbers. They could make arithmetical calculations involving complicated fractions. They also had some simple notions of geometry. They were familiar with the elementary properties of circles, cylinders, rectangles, triangles, and pyramids. It is, however, very doubtful whether they were capable of doing much more than solve mathematical problems connected with the affairs of everyday life. Everyday concerns were what really mattered to them. Out of their daily problems grew the body of rule-of-thumb procedures at their disposal, and what theoretical knowledge they possessed was directly rooted in practical needs. Things like the measurement of fields, or like the estimating of crop yields for taxation purposes. Or again, problems like the distribution of rations to the army. This wall painting, which also comes from the tomb of the vizier Rekhmire, illustrates another sort of problem they faced, one familiar to a schoolchild of our own day. how to calculate the number of men needed to make bricks for some building project, how to work out the total number of men required on the building and the number of bricks they would need. They seemed to be engaged on the building of a large brick ramp for hauling stone blocks up to a higher level. So, although they possessed no real science in the modern sense, the ancient Egyptians did have a body of empirical knowledge for dealing with the ordinary problems of existence. The annual flooding of the River Nile was a permanent concern for them. They developed ways of measuring the rising of the waters and predicting the course of the flood down the length of the land. This building is at Aswan, in the far south of Egypt. It houses the records of the Nile's flooding at various times. The levels are marked as lines on blocks of stone set at different heights up a flight of stairs inside. The building is of ancient origin. It belongs to the latter days of ancient Egyptian civilization, but many of its records are more recent, even extending into this century. Sometimes the technology of the ancient Egyptians, as distinct from their science, could accomplish enterprises that would have fully challenged the ingenuity and resources of the modern world. In some instances, we still do not know for certain how they went about their work. Such is the case with the pyramids. Fortunately, some of their other engineering achievements are better understood. There is, for example, the erection of large obelisks, those spires of granite like Cleopatra's Needle. The obelisk of Sesostris I in Cairo, 87 feet high and weighing 120 tons, was erected as early as 1900 BC. The Egyptian masters of works who put up these obelisks were very capable men. Men like Sennemut, who raised obelisks at Karnak, or the man responsible for the pair in front of the temple at Luxor. One of these was removed to Paris in 1836, and its pedestal is now bare, but the other still stands on its original emplacement. The full technical achievement of the ancient Egyptian is best appreciated, however, by examining one of his failures rather than his triumphs. The unfinished obelisk which lies in a granite quarry at Aswan, still attached to the bedrock. It is 137 feet long, and if it had been extracted, would have weighed nearly 1,200 tons, 3 times the weight of its nearest rival. As it is, the trenches that form its sides go only so deep. It was not because of an engineering miscalculation or a failure of nerve that it lies abandoned. A series of fissures in the lower bed of the granite were revealed as work progressed, and the engineers were obliged to abandon their task. They knew that with these flaws, the obelisk would inevitably break in the middle at some stage if they tried to get it out. To find a suitable mass of granite, the ancient Egyptian quarrymen had to go down to a considerable depth. The upper layers of rock had to be removed. This was achieved by lighting fires confined between mud brick walls. The mud brick walls determined precisely the area of rock to be heated up. This modern demonstration shows how the process works. When the fire begins to die down and the rock beneath it is sufficiently hot, the smouldering material is removed. Now the rock surface is drenched with water. This causes the surface to shatter to a depth of perhaps an inch. More of the heat-treated surface could be broken up by pounding it with balls of tough stone called dolerite. These lumps of dolerite occur naturally in the adjacent desert valleys. This process of heating up, quenching and pounding the rock was continued until a flat surface forming one side of the obelisk had been obtained. Some of the tools and devices that were used for such work have survived to this day, like these copper chisels and crowbars in the Cairo Museum. These interesting items are boning rods. They were for estimating the flatness of plane surfaces by moving a center rod along a string stretched between other rods of the same height. Ancient Egyptian drawings show them in use by the stonemasons. When the side trenches had been sunk to the required depth, the most laborious part of the work began, that of mining galleries at intervals under the mass of the obelisk, pounding the stone from both sides until the obelisk lay attached at a few points to its bed by stone supports. These galleries were filled with suitable rubble packing, while the remaining supports were bruised away, so that eventually the monument lay detached on a bed of rubble within its huge trench. Now the obelisk had to be removed from its site to the river bank for transport to its destination. That meant getting rid of granite outcrops that would interfere with its passage. This was done by pounding wedge slots along a selected line in the granite and then hammering in metal or wooden wedges. Probably large levers in the form of tree trunks were used to rock the obelisk out of its trench and roll it onto the slope of sand that led to the river bank. At some stage in its removal, it was attached to a wooden sled by rope tourniquets. This picture shows such a sled pulled by oxen, though the large stone block is not an obelisk in this case. It then had to be loaded onto a barge for transport downstream. In the temple of Queen Hatshepsut at Thebes, there is a relief of the ship that brought her obelisks from Aswan. It must have been a very large vessel to accommodate the enormous obelisks on its deck. It was towed by at least 30 ordinary craft. Queen Hatshepsut put her obelisks in a narrow space between other buildings, so the Egyptians must have been able to raise such monuments within a restricted space where long levers could not be used. We know that the Egyptians had a method of erecting great statues by dragging them over mud brick compartments filled with sand. By emptying sand from the compartment under the statue, it could be made to settle into the desired place. This method was also used in the construction of pylons or gateways, and a similar method must have been used for the raising of obelisks. If this method was used in erecting the obelisks, a very large temporary mud brick construction must have been employed. This model illustrates how a great embankment of mud brick could have been built in front of a temple gateway, with a funnel to let down the obelisk in the required place. The obelisk itself would be securely lashed onto a sledge, ready to be dragged up the slope of the mud brick ramp. A roadway of logs set in the ramp and greased with animal fat would smooth its way to the top. The obelisk would be dragged up the slope by teams of men hauling on ropes, until its sledge began to overhang the funnel down which it was to go. And remember that these monoliths weighed several hundred tons. The funnel is shown cut away here. It is filled with sand and narrows to its base so that the obelisk can come down in a precise position. Tunnels were made through which the sand could be removed when the time came to lower the obelisk. First, the overhanging part of the sledge is released and removed. At this point, the obelisk is tipped base down onto the funnel of sand. Now the sand is cleared from the funnel through the tunnels at its base. The sand level in the funnel starts to fall and the obelisk descends onto it. As it does so, it comes clear of the remaining half of its sledge. As the sand level falls lower and lower and the funnel narrows, the base of the obelisk is directed down towards the pedestal stone already in position at the bottom. Guide ropes attached to the obelisk help to control the final stages of the descent. When all the sand has been withdrawn from the funnel, the obelisk is left standing on its base. All that remains is to clear away the enormous mud brick ramp, leaving the obelisk standing free in front of the gateway. The stone pedestals were cut with a channel along an edge of the upper surface to locate the butt of the obelisk before it was finally pulled upright. In the case of Hatshepsut's remaining obelisk at Karnak, it has come down on its pedestal askew, missing the notch entirely. The notch was subsequently filled to improve its appearance. Although it has come down out of square, the obelisk still stands, one of the 4 or 5 such monuments still upright in the land of its origin. The pounding out of these great monuments from granite beds, their transport by river, and finally their erection within a restricted space, presented the ancient Egyptians with engineering problems which they triumphantly surmounted. How long did it take to fashion and install the obelisks? On the pedestal of the still-standing obelisk of Queen Hatshepsut, the other one lies broken on the ground nearby, she has left us this dedicatory inscription.
O you who shall see my monument in after years, O those of you who shall speak of what I have made, I swear, as the sun god loves me, and as my father our moon favors me, as I rule this land like the son of Isis, so surely these 2 great obelisks are made from one block of hard red granite, without any patches or flaws. I ordered work on them from the first day of the winter season, year 15, until the last day of the 4th month of the summer season, year 16, making 7 months of work in the quarry.
And on another side of this same obelisk, this very determined and powerful queen leaves us with a final warning.
Let not him who hears this say, it is a lie, but rather let him say, how like her, who is truthful in the sight of her father.